Student, today we are going to see Intext 3.11. Suggest a list of metals which are extracted electrolytically, right? The metals of group 1 alkali metals, group 2 alkaline earth metals and group 13 aluminium are extracted by this electrolysis process. Let's see why. We take one metal, other of this, right? Take zinc carbonate. If we go by conventional method, that carbonate converted into oxide by the calcination, right? Then that oxide is reduced by any reducing agent like carbon to zinc, right? But if we take the metals from these metals, then first we carried out calcination and get calcium oxide, right? After that, when we carried out reaction with the reducing agent, it not reduced to metal, but it formed calcium carbide. So we can't use this conventional method. Then we have one other option. We can take the chlorides of these metals, right, and pass electricity, carried out electrolysis. By the electrolysis, we can get metal on cathode, right? Next, 3.12. Consider the reaction Cr2O7 minus 2 plus 14H plus 6 electron. It gives 2 CrO3 minus plus 7 H2. What is the quantity in coulombs to reduce 1 mole of Cr2O7 minus 2? Here we have to reduce the dichromate ion into Cr plus 3, right? And we have to find out what quantity of charge is required, right? Write this equation again. Here you can see that 1 mole of dichromate required 6 electron to reduce into Cr plus 3, right? How? You first of all find out the oxidation number of Cr in dichromate, right? 2 Cr plus 7O equal to minus 2. If suppose chromium having X oxidation number, we know oxygen having minus 2 oxidation number equal to minus 2, 2x equal to minus 2. This terms goes other side of equal to, it will be a plus. So minus 2 plus 14 equal to 12. 2x equal to 12, then x equal to 6. Means one chromium having plus 6 oxidation number. Plus 6 to plus 3, it's reduced. Means 3 change of electron is 3, right? For one chromium ion. Then for 2 chromium ion, it will be a 2 into 3 equal to 6, right? So there will be a 6 electron will be required. So we can write that 1 mole of dichromate ion requires 6 Faraday charge. 1 mole of electron equal to 1 Faraday. Here 6 electron are required. So we can say like that 6 Faraday charge is required. Equal to 6 into 96500, right? 1 Faraday is equal to 96500 coulomb. So replace that value. You will get 5.79 into 10 to the power 5 coulomb, right? Now in text 3.13, write the chemistry of recharging the lead storage battery, highlighting all the materials that are involved during recharging, right? We have to show the chemistry of recharging of lead storage battery. We know that the lead storage battery is secondary battery. Secondary battery means we can use it so many times. Means one time it's that we can recharge and use again, right? In car or scooter we use that type of battery, secondary battery, right? First of all, see the chemistry of discharging of that type of battery, right? In lead storage battery we use lead as a anode and PbO2 as cathode, right? And they are dipped in the 38% concentrate H2SO4 solution, right? Discuss how this battery work. right? Means discharging of this battery. We take lead and anode, right? Means there is a lead, and we having a solution of H2SO4 means H plus ion and SO4 minus 2 ions. So there is the SO4 minus 2 ion in solution and lead at anode, right? Whenever at anode we know that oxidation take place, so Pb donate 2 electron and form PbSO4. Means there will be a generation of production of PbSO4 at anode, right? Now see the cathode reaction. Yeah. On cathode we take PbO2 film, right? Means we having PbO2. That PbO2 accept 2 electron. In PbO2 the oxidation state of Pb is plus 4, right? Here is 2 positive ion. One is Pb and one is H plus from H2SO4, right? But Pb accept that electron. You can understand by the electrochemical series, right? Now it accept 2 electron and converted into Pb plus 2. That Pb plus 2 react with SO4 minus 2 and generate PbSO4. Means also PbSO4 generate at the cathode, right? Means at anode and cathode both on that electrode PbSO4 is generated, right? Now see the recharging. Whenever we have to recharge the battery, means we have to carry out reverse reaction of that discharge reaction, right? Now see at anode PbSO4, right, which is generated during discharging, that accept 2 electron, right? Means the reverse reaction of this anode reaction. PbSO4 plus 2 electron. It gives Pb plus SO4 minus 2, right? Opposite reaction of this anode discharge reaction. Now at cathode there is also PbSO4 which is generated during discharging of battery. That PbSO4 react with H2O, right, and will generate PbO2, SO4 minus 2, H plus and donate 2 electron, right? Opposite of this cathode reaction, right? We know that any chemical cell can be worked as a galvanic cell and as well as electrolytic cell, right? In discharging of reaction, it is work as galvanic cell, right? In which spontaneous reaction is occur, right? And we will use the electricity, right? In recharging of battery, it is worked as the electrolytic cell, right? Electrolytic cell means we provide its electricity and carried out the reaction, reverse reaction of this, right? Means by the help of electricity, right? We carried out this non-spontaneous reaction, and during this recharging we again get H2SO4, PbO2 and P as we started from earlier, right? Means again we can use that battery, right? Hope you understand. Intext 3.14 suggests 2 materials other than hydrogen that can be used as the fuel in fuel cell. They are methane and methanol, which can use as a fuel in fuel cell, right? Now in text 3.15, explain how rusting of iron is investigated as setting up of an electrochemical cell, right? In this question we have to show that the rusting of iron is worked as an electrochemical cell. We know that in the presence of moisture and air, iron get corroded, right? Means iron get oxidized into ferrous, right? Suppose we have a one iron rod, right? Suppose there is some spot, right? At that spot, in the presence of moisture and oxygen, that iron molecule get oxidized and form ferrous, right? And produce 2 electron, release 2 electron. That 2 electron moves from that rod, right? This reaction is oxidation reaction, so we can say that that is our anode, right? Means that spot is our anode. At anode, 2 electron producing, right? And they are moving forward, right? In the presence of H plus, right? In the presence of H plus, that electron reduce the oxygen of atmosphere, right? We know that there is also carbon dioxide in atmosphere. H2O combined with carbon dioxide and form H2CO3. It's a carbonic acid. H2CO3 means H plus and CO3 minus 2. Right? Means there are H plus ions. In the presence of that H plus ion, that oxygen reduced by the electron. Right? Means the 4 electron accept that oxygen and it will combine with hydrogen and form H2O. Right? Here reduction occur. So we can say that that reaction occurs at cathode. Means another spot is our cathode. Right? At anode, ion oxidized and remove 2 electron. That 2 electron moves from that iron rod, right? And that electron reduce the oxygen and form H2O, right? That one is our cathode anode reaction. That is our cathode reaction. So we can say that our overall reaction is 2Fe plus O2 plus 4H plus that electron, and that electron will be cancel out. We multiply by 2 for the balancing the reaction, right? So we can say that 2Fe plus 2Fe plus, it gives 2Fe plus 2 plus 4 electron. 4 electron cancel out, right? Now we get 2Fe plus 2 plus 2H2O. We have to show the rusting of iron. It is not a rust of iron. We know that the rust of iron means Fe2O3 into XH2O, right? In the presence of moisture, that ferrous ion again oxidize, right? Means here Fe plus 2 is produced. Also moisture is there. In the presence of moisture, that Fe plus 2 is again oxidized by oxygen of atmosphere and form Fe plus 3, right? It form Fe plus 3. Means form ferric, right? That ferric combine with oxygen and form ferric oxide, right? Ferric oxide is surrounded by that water molecule, right? Means the hydrated ferric oxide form, and hydrated ferric oxide is known as rust, right? Means during the rusting of iron, there is our oxidation reaction occur, as well as reduction reaction occurs, right? And there is the formation of some chemical cell. So we can say that the rusting of iron is one type of electrochemical cell, right?